Hello, this is Pick, and welcome back to my guide for FTB NeoTech. Last time we fought a very annoying Ender Dragon. It was so annoying that it ended up getting removed in the next update. So I guess I wasted my time for nothing. Or maybe I saved you guys the pain. In any case, I'd like to upgrade my BlazBloom Goo into VoidShimmer Goo. To do that, we need the Dragon's Breath we got last episode. You can't just put in the input ingredients and expect it to work though. I'm going to need some upgrades in it to allow it to use more energy per craft. Generally speaking, this only works for efficiency bonuses, but it also works for certain recipes if they have a higher power tier than what is required in the machine normally. So, by claiming some of these upgrades from a quest, I can simply use them. Thankfully, the Chemical Reactor quest has some upgrades sitting there for us. So I can just claim those upgrades now and use them before I can actually craft upgrades myself. Much like the previous tiers of goo, place the corresponding blocks around the goo and it will transform it into the different types of materials that you get. In this case, we will be putting diamonds around it to turn them into Celestigems. Of course, it processes the lower tiers quicker, much like the BlazBloom Goo did for Primogel recipes. There are 3 major upgrades that come with Celestigem equipment. The first is that we can finally make a Paxel. What this means is that I can have an axe, pickaxe, and shovel all within one tool. The second is that it can use energy instead of just durability. While the BlazBloom tools were able to be repaired in lava, the Celestigem tools can simply receive any type of redstone flux, forge energy, EU, in this case, whatever. The gimmick specific to Celestigem though is that it can teleport drops. By shift right-clicking on an inventory with the tool, it will send anything the tool does when performing its function into that chest. For pickaxes, shovels, and axes, of course, it sends blocks mined into that chest. The hoe makes soil that retains the BlazBloom soil's functionality of auto-harvesting, but also can now teleport the drops to a chest or whatever inventory. Likewise, the sword will also teleport the drops it gets when it hits things. Given that I have a lot of diamonds now, I'm definitely going to make a Paxel, but there are of course other things we can use Celestigems for. My Paxel doesn't hold a lot of energy though. How about we fix that? With a pocket generator, I can produce energy on the go. Around now is the point where it becomes available to you anyway, as you need a centrifuge in order to get the carbon dust. The pocket generator will generate more energy the better fuel you give it. However, better means better tier within Just Dire Things, not the burn time. The best total possible fuel for it would of course be the tier 4 coal blocks. In a way, it's like a battery. I mean, it is a battery, it stores 1,000,000 RF in it, which is quite a lot, but it'll keep replenishing that supply as you go. Just make sure you have enough fuel for it. I think it's about time the energy infrastructure got another upgrade. This time we'll be improving the fuel used to make it. Charcoal itself is all good and fine, but we can use a barrel to compact it into charcoal blocks. Charcoal blocks can then be processed with BlazBloom Goo so that we turn it into Primal coal. Primal coal then gets turned into coal coke. But how do we do all this stuff? Well, we have some new automation tools at our disposal that will make things much easier. Firstly, we can use a block placer. This is from Just Dire Things, and it does exactly what it says it will do. Place blocks. In this case, the charcoal blocks that we're sending into the machine. Of course, you'll want to make sure that you set up your filtering properly so it doesn't clog with the regular charcoal. It might also help to set up slot memory in the barrel, just so you can ensure that the slots don't all fill with charcoal blocks and not leave any room for charcoal, or vice versa. Next, of course, is a block breaker to go with our block placer. This particular one, being from Just Dire Things, requires a tool in order to be used. It will eat the durability from the tool, and it will keep running as long as the redstone signal is met, obviously. Each of these Just Dire Things blocks has some type of redstone control to it, and you can adjust it by just clicking on the button. The third thing needed is a sensor. This is what's going to look at the block and tell you what it is. Because we don't want the block breaker working all the time, we only want it running when the right block is there. So the sensor will tell us when the primal coal is present, and it will emit a redstone signal, telling the block breaker to break the block. None of these things are very high-tech or complex, so you could have set this up much earlier than I did. But I am going to make a change that's not available so early. By taking this block breaker and turning it into an advanced block breaker, we get a larger range of functionality and some very important upgrades. The main thing here is that, unlike its predecessor, this can accept energy. Why energy? Well, if we put a Celestigem tool inside the block breaker now, it will automatically replenish its energy from the energy provided by the advanced block breaker. In addition, you might not need the sensor at this point because you can ensure that it only breaks the primal coal. Like with most other types of filtering, you can simply drag from JEI, or I guess EMI, whatever. You can also determine where it's going to break blocks at this joint. So if you only want to break blocks a certain distance away from the block breaker, you can do so. Do note that you can't orient the block breaker like this. You simply don't need to. Another perk is that you can still teleport the drops from the Celestigem pickaxe, so you can still set an inventory at a range and it'll put the drops in there without needing an item collector. The last thing to do here is set up a coke oven. So once you have your primal coal in place, simply import it into the item input and have that go in the coke oven, and with some steam, it will produce 2 coal coke per primal coal. In addition, it will not produce creosote using this method, so you do not need a fluid output. The coke here will end up replacing the charcoal that's going into the steam boiler, as obviously we have no need to keep it in the regular charcoal state. If I really need more regular charcoal, I can always take some out of the transmutation table. By the way, on 1.5 it works properly now. 1.5 fixed a number of bugs, some of which I've mentioned in the past. Now I think it's a good time to start making some p-doped and n-doped silicon plates. By using these in place of the regular silicon plates, we can get double output on transistors and diodes, essentially cheapening electronic circuits by a fair margin. My next goal is going to be upgrading the large bronze boiler. Now I can make it the advanced large bronze boiler. This will burn fuel faster but also produce much more steam. Upgrading it is a fairly straightforward process. You just need to be mindful that you'll need to move your controller up a block if you want to keep most of the structure in the same place. It's also 1 block taller, so keep that in mind too. This thing produces 4 times the steam of the original boiler, so for how cheap of an upgrade it is, it's absolutely worthwhile. To convert that to turbines, you'd say instead of 8 low voltage turbines, that handles 8 medium voltage turbines. Instead of 256 EU per ticket power, it's 1024. Now's a good time to get started on automated ore processing. For my first 2 sets of macerators, I'm going to be using them for the components of battery alloy, as that's something we don't quite have automated yet. By the end of this episode, I'll have most of the ores taken care of between the bronze and steel drills. You'll want to handle them in pairs because, of course, you're going to have to either produce raw ore or crushed dust, and then turn that into regular dust in both cases. Power is far too insufficient for this though, of course, so I'm going to need to add some more steam turbines to keep up with demand. Not that I'll be running optimally by the end of the episode, but this'll have to hold me. I'll be doing all of my ore processing on the next floor. Might as well keep things in sections of the base, right? That being said, this is probably the extent at which I'll be making the size of the network bigger. For right now anyway. Low voltage infrastructure is only going to handle us for so long. But of course I don't have the materials to move to medium voltage just yet, at least for the whole base. Now with that in place, I also will be setting up a bunch of mixers and furnaces to process all of this alloy. In the update that doesn't quite exist yet as of this recording, but does exist as of me narrating the video, there's a new machine called the Alloy Smelter, which means you don't need mixers and furnaces, you can do it in one machine. I'm just gonna stay consistent and keep using this method. Also, get used to seeing me putting down a whole bunch of machines for automation in this episode. We're gonna be putting down a lot. And now to continue the giant wall of compressors. It's only gonna get bigger as the episode progresses. So many plates and other things that require this machine. But it's all worth it though, because now we have everything we need for automated battery production. And when you're doing this automation, remember to have it so that it takes out via pipe and doesn't just output to a machine. Because, you know, for batteries you need both battery alloy plates and curved battery alloy plates. So you can't just output all of your plates into the curved plate maker, because then you wouldn't be accessing those plates on the rest of the network. While we're on the topic of lead-based alloys, how about we go over soldering alloy next? I mean, we've already made it, it's just a combination of tin and lead. I guess that's something the alloy smelter can't do though. So because of that, keep a stash of both dusts and ingots. It's most convenient to have both available because you're gonna need both for a lot of different things. And of course I need a way to smelt down this soldering alloy, so I've gone ahead and reused the old cupro-nickel coils from the original blast furnace, and I've repurposed them to make a blast furnace that melts down soldering alloy into molten solder. Like the lubricant, I will be putting all of these soldering alloy recipes in one corner of the building, that way I can centralize them. I should have plenty of room in that corner for all soldering alloy recipes within the mod pack. The first thing I'll be making with molten solder is steel gears. They're something I need an absolute ton of for both making machines and item pipes. Of course, I already have steel rods and rings set up from last time. Or well, I guess I don't have rings yet, but look, I'm going to be making a bunch of machines today, so if I get a tiny detail of when I did something incorrect that was so insignificant that you would not need help with it, just don't worry about it. Just know, automated steel gears, cheap, good. There, steel rods for the compressor wall. Now I've done it. I'm not going to draw attention to desyncs like that in the future. The way I record these is that I just record all of the footage first, then I narrate it later and just kind of look at the footage and see what I did. So it's not exactly organized, but it saves me a ton of time in like writing an actual script. I'm not the best at ad-libbing, but whatever, I make it work. And now here's a mix-up of all the stuff we've done. This is what it all comes down to. We're making steel machine casings, we're making basic machine hulls, and we're making redstone batteries, as well as tin cabling. The tin cabling is being made in a packer next to this assembler. And eventually I'll remember to put the redstone battery into the input of that big assembler, so that basic machine hulls are more or less automated. And despite how exasperating that all was, we're nowhere near done with all of this stuff for today. Today is a big episode for setting up machine automation. I'd like a machine mall ready by the end of it at the bare minimum, and of course I'll have one. There we go, isn't that beautiful? I might as well take this opportunity to show off a different mechanic. If you have some lubricant in a bucket and right click on a machine with it, it will add 40 efficiency to the machine's current process. If it can't hold 40 more efficiency, it won't work. Though you might be able to do it with a tank and have it input everything. I'm not sure about that though. In any case, it's like having a temporal pouch, but isn't the temporal pouch. It does help when getting the efficiency up and running to bootstrap a machine though. I'm gonna have to wait for more materials to come in, as the steel furnaces are a little slow. In the meantime, how about we set up a storage room? I'm going to have a bunch of limited barrels ready to go with all of the components I ever would need, as well as just a general backlog for materials from the quarries. While I don't know exactly how things are going to look, generally speaking I'm going to make each column a different material. You'll have the ingot, you'll have the dust, you'll have the plate, you'll have the gear, you'll have the wire, depends on what's applicable. I'm also designing it this way for a particular reason. Or, well, I thought about it and maybe this wasn't the way I was supposed to be doing it, but it's the way it is now, so that's that. All of these barrels are connected for a reason, but I'll get to that later. What I'll get to now is the entire item pipe network I've attached to the front. By using this, I can have a backlog of materials in the system at any given time, as I said. The priorities here chosen are very particular, as they will always fill from -10 inputs, but things will always go to higher priority destinations on the network first, such as machines. Another important thing is that the input priority is lower than the output priority. This ensures that the barrels never fill back into themselves. I call this design the parallel plate design, but if I have it resemble the parallel plate capacitors I was thinking of, it might look a little different in the end. Might also be a lot more expensive than what I end up going with. Also, I can make sure to put the memory on each of these barrels so that they only store the thing they're supposed to be storing. Here's a quick overview of things. Ultimately, I probably should have put the pipes on the back of the barrels, because then you could see what's in them better. But again, I had another idea for the design, and things might not work out the way I thought they were going to. Just know that this is the main storage room. I will be storing other types of components in here, but I started with all of the basic materials. While I'm doing all of this mass moving of items into the main network from the main dump barrel, which is just a barrel that has a low extraction priority on it, and an empty blacklist. I should mention now that if you put motors into the specific slot in an item pipe's GUI, you can have it extract at a much higher rate. Regular motors do an extra 2 per motor, so if I put in 16 motors, that's plus 32 items and 48 total, because it starts with 16. This applies to all items in an inventory, not just a particular stack. So this dump barrel will send things to wherever it needs to go, and if it finishes a stack, it'll just move to the next one. The next thing that needs an upgrade is steel production. Steel is something that I need a ton of and have no production rate for. So, in order to alleviate this, I'll be borrowing my centrifuge. By centrifuging coal dust, I can turn the coal dust into carbon dust, and then that goes in the blast furnace with iron dust to make steel at a much faster rate than we were making it previously. And with the rollout of new machines for processing, I've set up macerators for iron and copper. Of course, I need iron dust for steel, so this is where my iron dust is going to come from. I have that large stash of spare metals for the time being, so I can afford to dump all of these dusts into alloying. That's the benefit of having that backlog running for the past 30 hours. Give or take. Okay, blast furnace up and running. These recipes make 5 steel ingots at a time, far faster than the long wait time of the steam blast furnace. This takes 20 seconds to make 5 ingots, the other furnace takes 30 seconds to make 1 ingot. And that's only the base rate, of course. If it gets its efficiency up, it'll start making steel extremely quickly, assuming you have the inputs, obviously, and that includes power. We'll get to power at some point. I don't think today, though. And of course, coal macerators are next, as we need a ton more coal dust for that carbon dust. How long should I even make these clips? Guess they should be clickable. Now, let's finally get to automating some machines, to the best of our ability. It should be no surprise that the first thing I would like to automate is assemblers. After all, we have the robot arms ready to go, right? I'd recommend looking at what machines I pair with what other machines so that you can get an idea of how to save on assemblers. To start, I'll be grouping the assembler, packer, and unpacker. Regardless of how useful a particular machine is, I'm going to automate it anyway. Now let's talk about a useful device, a configurable chest. What this can do is you can filter all of its slots and determine how much of a given item is in it, much like you can do for the slots of any modern industrialization machine. The way you would set the filter is of course to drag in from EMI, put it in the slot, and use the scroll wheel to configure the amount. And of course I want this on a high priority because I want all of the machines being made to come into here. And now I don't have to search all of those assemblers every time I want to pick up a machine. Everything will be right here, and it doesn't cost any power. Alright, let's make Invar gears next. To make Invar gears, of course I'm going to need Invar plates and rings. To make those, I need to compress Invar rods and ingots, so I'll need a cutting machine for Invar, and then I'll have the Invar ingots be produced with a mixer, because that has to turn iron dust and nickel dust into Invar dust, and I smelt that. And to get the nickel dust, I simply have to process nickel ore with macerators. You can see how this stuff goes. It's not difficult, but there are a lot of steps. And of course, you'll need to keep track of everything. With these Invar gears, I can make Invar rotary blades. I'll also make conveyor belts alongside it with large motors to save space on assemblers. Our next trio of machines is the electric furnace, mixer, and Wiremill. Regardless of if I have things set up or not, I'm prepping these assemblers for machines now. I'll make more of the components over the course of the episode. I'll also get item pipes and fluid pipes going now that I have the materials. I guess this means now I have one of every different type of transport. Another trio is the Macerator, Compressor, and Cutting Machine. I don't know if I got footage of this explicitly, so I'm just gonna mention it now and put the video chapter. That'll tell you what I combined. Electrum will be next, as I'm already processing lead and that means I'm making raw silver. I am also producing silver ore, so I'll be making it from that as well once I set up some macerators for it. It seems that silver ore produces uranium when macerated. I don't know quite if this was intended, but I guess we have uranium now. Not that I really have a use for it yet, it's just gonna sit in storage. I've started working on all the other types of ore processing. That's all you really need to know. I'm gonna start skipping all the minor stuff from here on out. Do you really want to see me set up all these individual ores and plates? You know how to do that by now. Finally, something somewhat interesting. After skipping through a bunch of clips, I've come across rotors. Not the most interesting thing ever, but you know, they have multiple steps. You'll need soldering alloy to make up for the bolts, as well as rings and those turbine blades. Turbine blades are made with curved plates and rods. So naturally we're going to set this up for all three materials. You can actually accomplish all rotors in 2 assemblers. Isn't that convenient? I'm starting to run out of my backlog of ingots. To combat this, of course I can just start smelting things. You could use mechanisms furnaces if you want, but I'm just going to use modern industrializations. How about we do something new and interesting? The storage controller works much like the ones from the Storage Drawers mod. Simply place it next to a network of drawers and it will connect to all of them. Or, barrels, my bad. Much like the other storage controller, you can simply right-click to input all items of a given stack into the system as long as they have a place to go and have a whitelisted place to go. It won't just dump your entire inventory into a simple barrel. You can both put in and take out from it. Though I think it is a little buggy with the modern industrialization pipes, hence why I made that massive network on the fronts of them. There are other ways of working with the storage controller though. We'll get to it soon, trust me. I made a bit of a mistake with my synthetic rubber automation. Yeah, the synthetic oil just mixed with the paper and that took priority over the sulfur dust, so I ended up completely throttling my output of rubber sheets. To fix this, now that I have electric mixers being auto-crafted, I just put down a second one, fixed the recipe, and had them processed separately. And there, now I have 6 times production again. Also, to increase the rate of production of synthetic oil, I put steel fluid input hatches on the coke ovens instead of the bronze ones that were there. In the 1.5 update, we got integrated dynamics. So I went exploring unclaimed chunks to find a mineral tree. You'll want to bring a Silk Touch axe, specifically. Thankfully, my Paxel has it. Break it down, collect some saplings, and return home. It might take you a while to find one, though. The reason why I said to use Silk Touch is because you can actually just make more crystallized mineral logs within the transmutation table. Then you'll have to break it normally without Silk Touch so that you can actually get the crystallized mineral inside. To get mineral resin, I'm going to need to jump on a squeezer. You'll want to put a tank next to it too. Reset the squeezer with a redstone signal. You won't have to do too much of this manually because you can upgrade to the mechanical squeezer pretty much right away. Some crafting later, and I can make a storage terminal. The storage terminal will allow me to access any connected inventory from one block. To use the storage terminal, make some item interfaces. Place one down on the inventory you want to connect to, could be a chest or a barrel, or it could be a storage controller. Then place down a logic cable, and on that place down the storage terminal. This will read anything connected to it, and you can hook up as many inventories as you'd like. So if I wanted to hook up the configurable chest, I can now access all of my machines in the storage terminal as well. The next thing I'd like to do is automate production of aluminum. Of course, the main source of this will be bauxite ore. So I've already set up macerators for it, and I'm going to be processing it in the electrolyzer. I'll be using my Canthal blast furnace for the time being. Eventually I'll move it into its own space. I kinda just want to get electronic circuits up and running. However, I'm going to run this on its own power network. This will help save all of the power on the rest of the network, as I'm very short on it as it is. So I made a medium voltage steam turbine, and that's going to handle all of the things on this little sub-network. Just aluminum production pretty much, and I guess the atomic reconstructor. Medium voltage turbines make 128 EU per tick, as opposed to the 32 with the low voltage. Next I'll get some unpackers in place, one for aluminum dust and one for antimony dust. These are going to be responsible for making P-type and N-type silicon. Unlike most machines, these are going to directly output into the chemical reactors, as I have no other use for these tiny dusts. It's a useful feature, the auto output, but it's something you should use sparingly. Next up will be the silicon dust itself, and I'll smelt that into ingots and compress that into plates obviously. But for right now I'm just going to craft silicon in batches. Sand is EMC-able, I can just make Certus quartz dust, and I can also make quartz dust from all the nether quartz ore I have. You get regular quartz ore from steel drills, so don't worry about automating supply of regular quartz. Sand is easily automatable, though I won't get to that, at least for today. And then I need to set up separate automation of Certus quartz crystals when the time comes. The smelting process and the plate making process can be completely automated though. And after all that, we have pumps, both the regular and large varieties. Solder will once again stand in the place of the bolts in the regular sized pump. Though I will be manually feeding electronic circuits for the time being, as I obviously don't have those automated yet and I need more machines that require large pumps in the first place. Make like 32 electronic circuits and you should be good to go. To bolster the production of aluminum, we're gonna need more ways of processing it. Eventually you're gonna want a second electrolyzer. Power will end up being the restricting factor, but currently processing rate is when I'm not using the temporal pouch. In order to deal with this, I'm going to start processing emerald as well. Emerald and lapis can both be electrolyzed to make more aluminum dust. For emerald you also get beryllium as a byproduct, as well as more silicon dust. Make full use of everything to make the highest rate possible of aluminum. Lapis also happens to give sodium and silicon. It makes for a good way to manage your ores, especially those you're not really going to be using too much. The last thing for today will be electronic circuits. So once I get all of that silicon in place, as well as the transistors and diodes, that pretty much organizes out everything. You know, make some electrum wire, turn that into fine wire, make all the cables, make all the electronic circuit boards, and that's basically everything for getting electronic circuits automated. Now, automated doesn't mean fast. It's still pretty slow, especially because of all of our bottlenecks, but I'll be dealing with that when I upgrade the power infrastructure in the next episode. I've pretty much gotten you to the point of automating electronic circuits, and that's a big step up from where we started. Today didn't really feature any progression, but it did feature a large amount of infrastructure. And believe me, you're gonna want infrastructure. Bare minimum, you should be passiving your plates, rods, rings, and other stuff of that nature. So, with this giant wall of machines behind me, we are done for today. Next episode I will be going through all of our cabling and upgrading it to medium voltage, so that means medium voltage power. For now though, thanks for watching, this has been Pick, I'm glad to have seen you, and I hope to see you again.